All right, today we're going to be looking at evaporated emission systems. And today we got ourselves a 2011 Chevy Express van. It's a 2500. Comes with the 4.8. Right here you can see it's EPA testing. And then right on here, the engine. So let's get right into it. We're going to start from the fuel filler cap right here. Come under from here, fuel filler cap right here. Our second EVAP purge valve right here goes into the tank, and then we come under the rail into our fuel tank. Then we go into our purge valve solenoids right here, and our charcoal canister, which is right here. And then from there, it gets cleaned, EVAP cleaned, and then it gets sent to the actual fuel lines to our purge cylinder up at the engine bay. All right, now that we've gone over the locations, why don't we actually go through each piece and the component. So we've got our purge valve solenoid. This controls the EVAP system going into the intake manifold and is commanded on by the ECM. Then we've got our purge tube check valve right here. And so these are for turbocharged vehicles. It makes sure the valve between the EVAP purge and solenoid and the EVAP canister to prevent pressurization of the EVAP system under boost. So this doesn't really apply to us because this is not really it is a naturally aspirated V8. This more applies for that 6.6 diesel that goes into this vehicle. But the EVAP canister filled with carbon pellets to absorb stored fuel vapor, and then from the canister until the control module that the vapor can be consumed in a normal combustion process. Then the recirculation tube, which is one used the fill pipe and the vapor tube in the carbon canister to refuel, kind of recirculate that fuel vapor. Then we got a fuel tank pressure sensor, so also known as an FTP sensor. Monitors fuel tank pressure and is a 5-volt reference, so it sort of makes sure monitors the fuel tank pressure, either a positive or a negative pressure. And so normally 2.5 is atmosphere, and then anything higher is above that, and anything lower is below 2.5. And so we have a fuel tank check valve within the actual fuel pipe to prevent any spitback during refueling. So any causes in pressure, it will make sure it will not spit back the fuel. And then EVAP canister solenoid valve, the controls fresh air flow to the EVAP canister, so it's also connected to atmosphere. And and then we have the fuel fill cap just to create a seal on top of that tank. So these are the components. Now let's go see the description. Now that we've gone up to the EVAP system operation, so it's to limit fuel vapors from escaping into the atmosphere from the fuel tank, because you have volatile fuel inside of your fuel tank. It likes to escape out of there, and so it likes to cause pressure, and we need to burn that fuel. So we use the EVAP tube and the EVAP canister to kind of clean that. And then sometimes if we bypass the canister, we can use the vent tube to atmosphere. And then we also have the purge tube to go straight into the intake manifold. And so that way the engine can use some of that volatile gas. So yeah, that's pretty much how it's done, is drawn through the solenoid vent valve and then the vent hose to the EVAP canister. And then fresh air is drawn through the canister, pulling fuel vapors from carbon. And then the air fuel vapor mixture goes through the EVAP purge tube to the EVAP purge solenoid into the valve in the intake manifold to be consumed by normal combustion. And so that's pretty much how that system works. Last thing we're going to go through is the different leak tests and different tests you can run on the EVAP. So purge solenoid valve leak test, it requires the EVAP solenoid does not seal properly, so we're kind of testing for that. ECM tests this by commanding the purge valve to turn off and the canister vent to be on to seal the system. So, and then while the engine's running, the ECM then monitors the fuel tank pressure and for an increase in vacuum, because that's what's supposed to be happening. And then the ECM will log a fault if the vacuum develops in the tank under these conditions. So we'll log a fault if vacuum develops. So we don't want vacuum because we want it to stay pretty much the same. And then a large leak test for pretty much giant like hole in the in any of the systems. So that produces from the enabling criteria, the EVAP canister vent is closed and EVAP's purge is open, so creating an EVAP in a vacuum in the system because it's pulling into the intake manifold. So then it monitors the FTP sensor voltage to verify that the system is able to reach a predetermined level of vacuum within a set amount of time. And if it's a failure, then there could be a large leak in the EVAP system or restriction in the purge path. Another way is the canister vent restriction. So if the EVAP system is restricted, fuel vapors will not be able to get purged from the EVAP canister. The control module tests this by connecting EVAP purge solenoid on and the EVAP canister vent off, and then monitoring the FTP for an increase in vacuum. And then it will set a DTC for if it does not over a set amount of time, then a fault will be logged. And then lastly, we've got a small leak test. So the engine is off, and the engine off naturally vacuum diagnostic monitors the EVAP pressure for the ignition off. Because of this, it remains active for 40 minutes after the ignition, and it will turn off. And so parasitic draw test pretty much of that with an engine off natural vacuum. When the vehicle is driven, the temperature rises in the tank due to heat transfer from the exhaust. And then after the vehicle is parked, temperature in the tank continues to rise for a period of time, then starts to drop. The engine off vacuum presents temperature change and corresponding pressure in a sealed system to determine the EVAP leak is present. So the engine off natural vacuum diagnostic designed or detect leaks all the way up to 0.51 millimeters. So it can actually test a hole that small. And so that's all your tests you can do. So now we're going to look at the EVAP purge solenoid. So it's a bit difficult to see, but see if we can get down in there. Our actual EVAP purge is right here, that little piece. So let's go back around so you can probably get a better view. So what's nice about working on this van, we can come back. What we're doing is we're looking at these hoses right here, and we're going to look at the solenoid, which is right here. And let's see if we can get back under there. Right there. That solenoid right there. Let's see. Right there. EVAP solenoid. Alright, now so we're looking at back at our live data. It shows that it is venting. Our purge percentage in duty cycle, pulse width modulation, our fuel tank pressure, and then right here is our fuel level percentage, but we don't really need to know that too much. Let's see if we actually put some throttle to it. We'll see if that'll change the EVAP vent solenoid. Changing our EVAP purge level, that's for sure. It's still venting our EVAP solenoid, but definitely changes our purge level. So let's just hold it for a second, about 3 grams. That's what we want to see, more purge percentage, that way you can get more fuel in there from that EVAP. Alright, now so we're going to look at some EVAP things. So we got some live data, it's saying it's venting, and it's actually doing a pulse width modulation. So fuel tank pressure, oh, there we go, it's starting to warm up. This engine is cold, so it's not going to have a lot of pressure in it for right now. It is a returning system, so it will eventually warm up after some time. See EVAP purge percentage, 0%. We're going to see later if we can get that to change.